Now, what exactly is atmospheric pressure? We're going to focus on that in this video. But first, we need to know what pressure is. Pressure is the ratio between force and area. Every force exerted on a surface will apply a pressure on that surface. Let's say if we have a book that's resting on a table. So here's the book, and let's say this is the table on which the book rests or lies on. The weight of the book will exert a pressure on that table. But it will exert it in this area over the one that's shaded in red. So the weight of the book exerts the pressure on the table. Now, atmospheric pressure is based on the weight of the atmosphere exerted on a surface. So the gas molecules in the air have mass, and anything that has mass can exert a weight force on a surface. And so that's really what atmospheric pressure is. It's basically the weight of all the air molecules above a given area. At sea level, the atmospheric pressure is 1 atm. So that's equal to 101,325 pascals. Now, 1 pascal is a force of 1 Newton exerted over a square meter. So at sea level, let's say if we have an area of 1 square meter, that means the length is 1 meter and the width is 1 meter. The atmosphere exerts a force of 101,325 newtons. So that's what 1 atmospheric pressure tells us. 1 atm tells us that all of the air molecules above that surface exert a weight force of 101,000 newtons over 1 square meter. Now, if you increase the area, the greater the weight force will be, but the pressure is a fixed value. So now you understand what atmospheric pressure is. It's basically the weight of the atmosphere above a given area. Now let's work on some problems. What force is exerted by the atmosphere over an area of 10 meters by 15 meters at sea level? So let's draw the surface that we're dealing with. Let's say this side is 10 meters and this side is 15 meters. So how can we calculate the force exerted by the atmosphere above this surface? We know that pressure is force divided by area. And if we multiply both sides by the area, the force exerted by the atmosphere is the atmospheric pressure times the area. Now the area is length times width. So we have a length of 15 meters and a width of 10 meters. So 15 times 10, that's 150. So the area is 150 square meters. Now the atmospheric pressure is 1 atm, but we're not going to use that value. We're going to use pascals. So 1 atm we know it's 101,325 pascals, or newtons per square meter. So the force is going to be 101,325 newtons per 1 square meter multiplied by 150 square meters. So as you can see, the unit square meters will cancel. And so the weight force exerted by all of the air molecules above this surface is 15,198,750 newtons. So that's the weight of the air above that surface. Number 2, A closed rectangular box with dimensions 5 meters by 8 meters by 12 meters is filled with air. What is the pressure exerted by the air on the bottom surface of the box? So let's say that's the box, and it's filled with air molecules. So the pressure exerted on, let's say, the bottom surface of the box is due to the weight force of those air molecules divided by the area of the bottom surface. So the length of the box is 5 meters. Yeah, that's right. And the width of the box is 8 meters. And the height is 12 meters. So those are the dimensions of the box. So with this information, how can we calculate the pressure exerted by the air on the bottom surface of the box? Pressure is force divided by area. And the force is basically the weight force of the air. The weight of something is just, we know the weight is mg. So we can replace F with the mass of the air times the gravitational acceleration. Now the mass of a fluid is density times volume. Density is mass over volume. So if you multiply both sides by V, m is P times V. So the mass is going to be the density of the air times the volume times gravitational acceleration. And the volume is basically the length times the width times the height. And the area of the bottom surface is the length times the width. So basically the pressure at the bottom can be calculated using this equation. The pressure is equal to the density of the air times the gravitational acceleration times how deep it is, or the depth, which in this example is 12 meters. Now let's go ahead and finish this problem. So the pressure is going to be the density of air, which is 1.29, times the gravitational acceleration times 9.8, and we want to find the pressure at a depth of 12 meters. If you want to find the pressure at this point, that might be maybe 5 meters deep relative to the top surface. So the pressure is 151.7 pascals. As you can see, it's not as high as the other example. Number 3. What is the mass of a vertical column of air that exerts a pressure of 1 atm over a 10 meter by 10 meter square surface? So let's draw the vertical column of air. So this is 10 meters, and this side is 10 meters. And so this is the square surface. And above it, we have gas molecules. Which we know will exert a weight force, just like the last problem. However, in this problem, our goal is to calculate the mass of air in this vertical column. Now, we have the atmospheric pressure at sea level, 1 atm. And so, at that pressure, we can calculate the mass of air. Let's say this is basically ground level at the Earth, and this is the vertical column that extends towards outer space. So we can calculate all of the air molecules that exist between Earth and outer space within this vertical column, which is 10 meters by 10 meters. Now we know that the pressure is force over area. And the force is basically the weight force, is mass times g. And the area is length times width. So to calculate the mass, we can multiply both sides by LW. So it's going to be the pressure times the area, which is length times width, and that's equal to mg. So the mass in this example is the pressure times the length times the width divided by the gravitational acceleration. Now, what number should we replace P with? You don't want to plug in 1 atm. In physics, you want the units of pressure to be in pascals, because 1 pascal is 1 Newton per square meter, and we have the area in square meters. So we need to use 101 and 325 pascals. The length is 10 meters, and the width is 10 meters, and g is 9.8 meters per second squared. So make sure to use units of Pascal for pressure and not units of ATM. So the answer is 1.03 times 10 to the 6 kilograms. So that is the mass of air that extends from the ground, that is from the Earth, to outer space within this vertical column of air, which measures 10 meters by 10 meters. So as you can see, there's a lot of air molecules between the ground level and between outer space. And so that's why the pressure is 1 atm.